So in this mini lecture, I'm going to cover two topics that are just add-ons to what we talked about in class on November the 4th. And this output right here is multiple regression output that we covered in class last Friday on November the 4th. And if you'll recall from that discussion, we were real pleased because we had quite a large adjusted R-squared, confirming our expectation. In our ANOVA table, we got a very small p-value, which allows us to conclude that the overall regression model helps predict our dependent variable, which is dollars of sales. And then when we looked at our p-values for our individual parameter estimates, all but one of the independent variables was a significant predictor of our dependent variable sales, and the variable that did not have a significant effect on the predictor as a predictor variable was experience. Okay? So now what I'm going to do here is I'm going to add just two more columns onto this output. Okay? I'm going to add two more columns onto this output. One column will be for what we call the variance inflation factor, oftentimes referred to as VIF, variance inflation factor. And then another column for standardized coefficients, which a lot of times you'll hear me refer to those as betas or standardized betas. Okay? So we'll go back to our data. This should be data that you're familiar with. And you can find that data, let me check here for sure. I think it's like around page 290 of the text. Yeah. No, that's not right. Page 288 of the text has this data, if by chance you want to look at it in the book. So we're going to, obviously we'll go to add-ins to begin this process, as always. And then we'll go over to Megastat, and we'll click on Megastat. And we drag down to correlation/regression. And then we'll go across and down to regression analysis. So this should now be familiar, because whether we run simple regression or multiple regression, we work with the same screen. And it asks for our independent variables. And remember that in Megastat, your columns of independent variables must be adjacent to one another. It's not that way in some other stats programs. And then for our dependent variable, it's just this single column for dollars of sales. But now, if you'll notice, I want to direct your eye to these first two boxes down below. And one is called variance inflation factors. That's that VIF item I mentioned just a moment ago. And also standardized coefficients. Okay? So we're going to ask the computer to add in two more computations for the variance inflation factor and standardized coefficients. And so now we're ready to just click on OK. And then you'll see the output. Now, I ask you to just take my word. First of all, here's the full regression analysis now. And you can check and compare memos, but I will ask you at this point, take my word that the output is essentially the same except for the addition of these two columns. Okay. The point estimates for the coefficients remain, I think, exactly the same, if I recall correctly. They remain exactly the same. The upper and lower bounds, I believe they also remain the same. In fact, I can look up here and see. Yeah, so here you can compare the two sets of output. So everything pretty much remains exactly the same, except for we've added two more columns. One for standard coefficient and one for variance inflation factor. So what I want to do now is speak just briefly about the variance inflation factor, and then I'll speak about the standard coefficient. The variance inflation factor addresses the issue of multiclinearity. Multiclinearity is a problem that we encounter when our independent variables are quote-unquote highly correlated with one another. Now, the way I've always worked with multiclinearity is I just look at the correlation table amongst the independent variables, and based on my inspection of that table, I decide whether or not I might have a problem with multilinearity. But the variance inflation factor does give us kind of a quick and easy number to look at. And you'll see here, these numbers range from basically 1.065 to a high of about 1.671. The rule of thumb for the variance inflation factor is if your numbers are less than 3, you don't have a problem with multilinearity. If your problems are, or if your variance inflation factors are between 3 and 5, it suggests that you might have a problem with multilinearity. And if you have any variance inflation factors that are 5 or greater, that's a strong signal that you do have a problem with multilinearity. Let me remind you 2 things. Number 1, multilinearity is an issue when you have your independent variables that are highly correlated with one another. And then number 2, the consequence of multilinearity is it artificially inflates the p-values. And it artificially inflates these p-values in this column here. So I think I mentioned this in the memo. I've seen data before. And let me also mention, multilinearity is a very common problem in social sciences, and the work that we do in business is basically all social science research. So I've seen situations before where we got a small p-value here, suggesting that the regression model does a good job of helping predict the dependent variable. But because of multilinearity, all of my p-values here were greater than 0.05. Now, it may be too early in your development to understand that, but if you have a small p-value here, at least one of these p-values should be less than 0.05, at least one. But if you have a small p-value here and all large p-values here, by definition, you absolutely positively have a problem with multilinearity. There's no doubt about that, okay? Because when your independent variables are highly correlated with one another, as I said earlier, it artificially inflates the p-values for each of the parameter estimates, okay? So this p-value corresponds to this parameter estimate. This p-value corresponds to this parameter estimate, and so forth. And remember, these B coefficients, these are point estimates. These are point estimates estimating the slope of the regression line. These are our point estimates, and then here's our 95% confidence interval for this, okay? And if we have a problem with multilinearity, the problem resides, well, the problem is seen in this column here because the p-values are artificially inflated. Now, one thing I will tell you is that even though none of the variance inflation factors here is 3 or greater, just from experience of looking at the data, I think this column or this row has a potential problem with multilinearity, and I'll deal with that in a separate mini lecture. But for right now, let me say that the variance inflation factor is a numerical indicator of multilinearity. If it's less than 3, it suggests you don't have a problem. If it's between 3 and 5, it's like maybe you have a problem. If it's greater than 5, it's a strong signal that you do. Okay? So that's the variance inflation factor. Now, in the case of the standardized coefficient, this column allows you to answer the question, which of my independent variables has the largest predictive impact on my dependent variable? Okay? Which of my independent variables has the largest predictive impact on my dependent variable? You can't look in this column to derive that answer because the independent variables don't work off the same scale. So what multiple regression programs such as VIF-Std do is they standardize the data. Now, I want you to take that term and kind of park it for right now. I'll actually deal with that in a class discussion, not in a mini lecture. But what VIF-Std or other multiple regression programs do is it standardizes the data and creates what's called standardized coefficients. Let me just say, in order to interpret this 0.877, what that means is for every 1 standard deviation change in our independent variable calls, we would expect a 0.877 standard deviation change in our dependent variable sales. For every 1 standard deviation change in our independent variable distance, we would expect a corresponding change of negative 0.186 standard deviation unit changes in our dependent variable sales. When we go to making predictions, when we go to making predictions, we use this column of numbers to build the regression model. But when we have to answer the question, which of the independent variables has the largest predictive impact on the dependent variable, we have to work with this column. Most people in business don't understand statistics well enough to really understand what the standardized coefficient means. So what you'll find when you work with a boss or with clients in business is you'll build regression models using this column of coefficients, but when somebody wants to say, so, of the independent variables, which ones are the most important, or which ones have the largest predictive impact, you deduce that answer from this column here. Thank you.